Now we want to look at factoring trinomials. That's where we have three terms. So as always, whenever you factor, you first check for the GCF, and then after that, you see how many terms you have, and that will determine how you try and factor. So now we're looking when we have three terms. These are called trinomials. And right from the start, I want to distinguish between two kinds of trinomials. In a minute, I'm going to factor this trinomial, x squared plus 6x minus 27. But I want to compare that versus a second trinomial that I'll factor in a different video, 2x squared plus 7x plus 6. All right, whenever you factor trinomials from the start, I want you to recognize one big difference, and that's what we call the leading coefficient. The leading coefficient is the number in front of the squared variable. You notice here, we say there is no leading coefficient, or really there's a 1 there, but we don't write the 1. But for the second trinomial, we have a 2. The reason why we want to make note of this is because we're going to factor these at the start in the same way, but after the first couple steps, this first kind, after a couple steps were finished, but a trinomial with a coefficient, with a number in front of the square term, we have a couple extra steps. Usually in class, I think of these as sort of easy to factor, and these, I always say they're a little bit harder because there are a couple extra steps. So for this video, I'm going to first look at what I call the easy ones and explain to you how we here at IB Tech teach factoring trinomials. I will do this example in a minute. Let me start out with an even simpler one. So here's a trinomial. There is no GCF. Since it's three terms, I'm going to factor this. And here at IB Tech, we teach what's called the product sum method. So you're going to hear me use the words product and sum. The product means multiply, right? So what I'm going to do here is I'm going to take the coefficient in front of my squared term, which is a 1, and I'm going to multiply it by my last term, which is a 30. This right here is what I'm going to call my product, or usually I just write PROD. So basically for this trinomial, my product is 30. Now this method's called product sum. The sum is simply the coefficient of what we call the middle term. So for this trinomial, my sum is 11. So here's what I'm going to do. I'm going to go off to the side. I'll make a little table. I'm going to write down my product is going to be 30. My sum is going to be 11. And what I'm going to do here is, here's the idea. I've got to think of two numbers. I'm going to break this 30, the product, into two numbers multiplied together. What are my possibilities? I can have 30 times 1, 15 times 2, 10 times 3, 5 times 6. I think that's it. So each one of those, if I multiplied those two numbers together, equal 30. I say that's a product of 30. But I'm then going to turn around and take these same two numbers and then add them together. So 30 plus 1 equals 31. 15 plus 2 is 17. 10 plus 3 is 13. 5 plus 6 is 11. Now here's what I'm looking for. I'm looking for my product to be 30. Well, actually all of these, the product is 30. But then I'm looking for a sum of 11. Well, 30 and 1 gives me a sum of 31. That's not what I want. 15 and 2 give me a sum of 17. I'm looking for 11. 10 and 3 give me 13. And finally, I look down to 5 plus 6, and that equals 11. So these are what I call my two factors. These are the two numbers. When you multiply them together, it gives me my product, which is 30. But when I turn around and add them together, it gives me my sum, which is 11. Now, with this kind of trinomial, and here's the key now, when you have a trinomial with a coefficient of 1 with no number in front of the square term, once you determine these factors, you're pretty much done. You can already factor, and you simply put your variable and one of your products, positive 5, so p plus 5 in parentheses times p, and then my other product, positive 6, p plus 6. So p squared plus 11p plus 30 factors into parentheses p plus 5 times in parentheses p plus 6. And once again, if you would take the time to multiply out these parentheses, if you would FOR them, or whatever you like to do, it's going to equal my original trinomial. So this is called product sum. So once again, to review quickly, the product is the number in front of the square term times the last term. The sum is the coefficient of the middle term. So once you determine your product and sum, then you're going to try and find two numbers that when you multiply the two numbers together, they equal the product. But then when you turn around and add those same two numbers, they equal the sum. And once you find two numbers that do both those things, then you've got your factors. Let's look at another example. X squared plus 6x minus 27. Now we just have to be careful with the minus sign because it is going to play a role. So let's do product sum. Once again, I want you to notice there's no coefficient in front of my squared term, so I consider this sort of an easy trinomial to factor. So my product is 1 times negative 27. So there's my product. And my sum will be 6. And now I have to think of two numbers that multiplied together equal negative 27, but when you add them equal 6. Now here's what's interesting in this case. My product is a negative 27. What has to be true when you multiply two numbers together to get a negative number? Well, one number has to be positive and one number has to be negative. So the two numbers here, I'm going to have to multiply a positive times a negative. So one number is going to be positive, one number is going to be negative. And what's also interesting is if I look at the sum, my sum here is positive 6. You know what that means? That means these two numbers, the positive number is going to be the larger number. How do I know that? Because when I add them together, I want to come up with a positive 6. So the positive number has to be larger than the negative number. So now I can try and list the two numbers that multiply together equal negative 27. And let me tell you, once you begin to factor trinomials in a while, a lot of times you can figure out the factors very quickly, almost in your head. So for instance, if I think about 27, 9 times 3 is 27. So I'm going to have positive 9 times a negative 3. So positive 9 times negative 3 equals negative 27. But when I add them, it equals 6. So there are my two factors, 9 and negative 3. So because I don't have a leading coefficient, I don't have a number from the squared term, I now can right away use my two factors, x plus 9 times x minus 3. Let me do just one more quick one just for practice. Maybe I'll write it down and you can even try it yourself. Maybe you can stop this video. Y squared minus 2y minus 15. There is no GCF. My product is 1 times negative 15, negative 15. Once again, I'm pretty happy because since there's no coefficient for the square term, this is going to be pretty easy to factor, hopefully. My product is negative 15. My sum is negative 2. So once again, two numbers multiplied together equal negative 15, but we turn around and add them, they equal negative 2. How about negative 5 times 3? Because then when you add them, it equals negative 2. Therefore, when I factor this, I get y minus 5 times y plus 3. Now let me show you one more quick thing that can happen sometimes. How about if I were to try and factor x squared plus 4x plus 5. All right? So my product would be 1 times 5 is 5. My sum would be 4. And now let's see if I can come up with two numbers that when I multiply them together equal 5, but when I add them equal 4. Well, actually, there's only two numbers that multiply together equal 5, and that's 5 times 1. However, when I add 5 plus 1, I get 6. So 5 and 1 is not going to work. But you know what? There are no other possibilities. There aren't any more numbers that multiplied together equal 5. So what does that mean? That means actually I am not able to factor this trinomial. And if you're asked to factor it, you would just say it's prime. For an expression to be prime means it cannot be factored. So there will be times when you'll be given some problems to factor and it turns out you can't factor anything, then you just say they're prime.